Okay, so for number 12, we're given an index collection of sets, and they're indexed by the natural numbers. And we want to find one such that each set within that family is a subset of the interval from 0 to 1. And for any two sets within that family, their intersection is not going to be empty, so they have stuff in common. However, if you take the intersection of all of them, it's going to be empty. So how can it be that if I take any two sets, right, it has to work for all of them? Any pair that you find, the intersection is not empty, but then the intersection of all of them is empty. So that may seem a little bit weird, but what we're going to do is we're going to put this in the number line. So this is 0 and this is 1. So we want to find the family is going to all be within this interval. So maybe what we're going to do here is we're going to fix the left-hand boundary. We're going to fix at 0, and we're going to let the right-hand boundary get closer and closer to 0. So maybe this length here is going to be, maybe this is a 1. Oops, okay, maybe this is a 1, right? It has this full length. And then maybe a 2 is going to be from here to here. And then maybe, I don't know, maybe a 3 could be from here to here. And maybe a 4 could be, anyway, you guys get the point. So we're letting the boundary get closer and closer and closer. So what is happening, you can see that any two of them, like if you take these two, you can see that they do have this whole stuff in common, right? If you take the green one with the pink one, they're going to still have this whole boundary in common. So any two of them that you take are going to have some numbers in common. However, the reason that the intersection for all of them, the reason that it's not going to have, they're not going to have any number in common is because, let me erase this. Oops. When we get super, super close, so we're getting closer and closer and closer to 0, right? The idea here is that the limit of this one is going to get so close to 0 that it's basically going to be 0. However, 0 is excluded from the interval, right? So at the limit, if they were to have anything in common, all of these intervals, as this gets closer, closer and closer and closer, what they would have in common is 0, but 0 is excluded. So in the limit, they're not going to have one value that is common for all of them. However, for any two sets that you can take, you can see that they're always going to, maybe let me put this in a different color once more. So if I get super, super close here, if I take these two, you can see that any two of them are going to overlap, right? So what we're gonna use this idea, and we're gonna say that our family is going to be the set an, where n belongs to the natural numbers, and each an is going to, it's going to be from 0 to 1 over n. So we keep the 0 where it is, and then this 1 over n, if we take the limit, that's going to be 0, but it's excluded. So so a 1 would be 0 to 1, a 2 would be 0 to 1/2, a 3 would be 0 to 1/3, and so on and so forth. You can see that this boundary is getting closer and closer and closer to 0, but they're never going to actually have 0 in common because 0 is excluded. So that is it for item 12.